Hey, future space explorers, ready to dive into the universe's most thrilling adventure? Today, we're launching into the next frontier where AI and space exploration collide. Get ready to blast off as we journey from the dawn of space travel with Sputnik to the cutting-edge AI-driven missions of today. Discover how AI is turning science fiction into reality with autonomous space missions, futuristic robots, and groundbreaking data analysis. From charting new cosmic pathways to envisioning human colonies on distant worlds, this video will take you on a mind-blowing tour of tomorrow's space tech. Strap in, hit that subscribe button, and let's embark on this stellar voyage together. Space exploration took a giant leap forward in 1957 when the Soviet Union launched Sputnik 1, marking humanity's first step into the vast unknown. Since then, we've gone from landing on the moon to sending robots to Mars, each achievement more remarkable than the last. But as the space agencies like NASA and companies like SpaceX push further into the cosmos, they've faced the growing challenges of human-led missions. Astronauts, though courageous, are limited by their physical and mental needs, and the time delays in communication with distant spacecraft make operations even tougher. This is where AI comes in that allows spacecraft to think and act on their own. With AI, spacecraft can analyze data, make decisions, and carry out complex tasks without waiting for commands from Earth. As we venture further from home, where communication delays stretch from minutes to hours, AI's ability to make real-time decisions is becoming more essential for future of space exploration. AI has revolutionized space exploration by allowing machines to operate independently in places that are far away and dangerous for humans. For example, spacecraft and rovers can handle unexpected challenges like sudden Martian storms or navigating tricky asteroid surfaces without needing constant guidance from Earth. This self-sufficiency makes missions more efficient and successful. Take the Mars Curiosity rover. It uses AI to decide which rocks to study on its own, speeding up its work without waiting for instructions from Earth. This is crucial in deep space, where communication delays are long. AI also keeps an eye on spacecraft health, predicting and fixing issues before they become serious, helping missions last longer and ensuring that important data keeps flowing back to Earth. Space exploration is a physically demanding endeavor, particularly when it comes to operating in environments that are just vastly different from Earth. The rugged terrains of Mars, the icy moons of Jupiter, and the asteroid belts of our solar system present unique challenges that require advanced robotics. AI plays a pivotal role in powering these robotic explorers, enabling them to perform tasks that would be impossible for humans or even traditional machines. Robotic arms with AI capabilities can perform delicate operations, such as collecting samples from an alien landscape or repairing a spacecraft in orbit. AI-driven drones can fly through the thin atmosphere of Mars or navigate the treacherous ice caves of Europa, gathering data that would be inaccessible by any other means. These robots are not just tools, they're intelligent entities capable of adapting to their surroundings and making decisions on the fly. The future of space exploration lies in these AI-powered robots, which will serve as our eyes, ears, and hands in the furthest reaches of the universe. Space missions collect an overwhelming amount of data, from stunning images of distant galaxies to detailed analysis of alien atmospheres. Sorting through all this by hand is not only slow, but also error-prone. This is where AI comes in. Using advanced algorithms, AI can quickly and accurately process huge volumes of information, uncovering patterns and insights that humans might overlook. It's become an essential tool for exploring the universe. Take the Kepler Space Telescope as an example. AI has been crucial in analyzing its data to find exoplanets, planets beyond our solar system that might support life. These AI systems detect tiny dips in star brightness, which happens when a planet crosses in front of a star. Thanks to this automated process, thousands of exoplanets have been discovered, some even in the habitable zone, where conditions might allow liquid water. AI also plays a vital role in the search of extraterrestrial intelligence, analyzing radio signals from space and distinguishing between natural noise and potential signs of alien communication. Imagine being lost in a vast desert with only the stars to guide you, knowing your journey could take years, even lifetimes. That's what space travel feels like. In the early days, spacecraft relied on carefully planned routes and constant updates from Earth to stay on course. But as we dream of exploring deeper into the cosmos, we need smarter, more independent navigation systems. AI could change everything. Imagine a spacecraft that adjusts its course in real time, dodging space debris or using a planet's gravity for a speed boost all on its own. With AI, these spacecraft could manage their fuel better, allowing them to travel further than ever before. In the future, we might see intelligent spacecraft making decisions, exploring unknown worlds, and sending their findings back to Earth without waiting for our commands. The dream of colonizing other planets has been a cornerstone of science fiction for generations, sparking our imaginations with visions of life beyond Earth. Now, with the rapid advancements in AI, this once distant fantasy is inching closer to becoming a reality. The journey to establish human outposts on the Moon, Mars, or even further afield is riddled with enormous challenges, ranging from creating sustainable life support systems to constructing durable habitats in hostile environments. AI is emerging as the key player that could help us overcome these hurdles, transforming space colonization from a wild dream into a tangible future. AI's potential in space colonization is vast, especially in building and maintaining habitats on other planets. Using advanced 3D printing technology, AI-driven machines could autonomously construct shelters, laboratories, and entire colonies from materials found on site, eliminating the need for constant human presence during these early stages. The advancement of AI in space exploration is like unlocking a new frontier, but it also brings about deep ethical concerns. With AI systems operating autonomously in the vast unknown, we face the risk of critical errors that could jeopardize entire missions. How do we ensure that these machines, far from human supervision, make the right decisions? The possibility of AI-controlled colonization introduces even more questions. What responsibilities do we have when creating machines that might one day operate without us? The thought of AI systems functioning independently without our oversight sparks a sense of unease. And also, we must consider how AI might interact with extraterrestrial life it encounters. Would a machine recognize the fragility of alien ecosystems? Or could it unknowingly cause harm in its quest for knowledge? These are not just technical challenges, but profound ethical dilemmas that we must face as we send AI into the cosmos. The dual-use nature of AI also raises the specter of space militarization. The same technology that propels peaceful exploration could be harnessed for war, making it crucial for nations to come together and establish regulations that prevent an arms race in space. The future of AI in space hinges on the decisions we make today. Thanks for joining us on this cosmic adventure where AI and space exploration are pushing the boundaries of the possible. Until next time, keep reaching for the stars.